Hey guys, you made it. Last lesson here, lesson 5.8. Not even a letter because this is the only one of 5.8. Kind of condensing two into one because they're both kind of shorter. We're going to be graphing absolute value functions. All right, we've worked with absolute value in the past. Our objective is to graph these absolute value functions and then translate the graph of an absolute value function. Translate it. All right, so there is some notes for this section. All right, definitely want to jot this down. An absolute value function is going to be a V-shaped graph. It could open upward or it could open downward. All right, and this is what it looks like. All right, y equals the absolute value of x, and here it is. It is a V. All right, the original vertex of the parent function of the basic is at 0, 0. All right, the vertex is at 0, 0. All right, vertex is where the two lines meet, the two segments. This is not linear, by the way. All right, this is not linear. All right, this is called a piecewise function, which we're not really going to get into too much detail about that. But right, so that's an absolute value function. Now, what a translation is when you shift or just move the graph. We either shift it upward, horizontally, side to side, vertically, up or down. Could be both. All right, so that V just moves its location. The result is the same size graph. It looks the same angles, but it's just in a different location. Okay, so this is the different ways to translate it. All right, this is going to be very important that you pay close attention. Jot this stuff down. All right, the first is a vertical translation. Vertical, again, just for your helpful, is up or down. Okay, up or down. It would look like this, where y equals the absolute value of x, and then plus or minus a number. That k is just the number they use. It's often for constant. They don't use c, but k. So if you add a k down here plus k, it moves it up. Or it's kind of thinking like a y-intercept in a way. All right, if you add it, it goes up. The vertex moves up that many spaces. That's what moves up. The vertex moves up. And if it's minus k, it goes down that many spaces. That's the vertex moves down that many spaces. So if it's plus or minus on the outside of the absolute value, it moves up or down. Okay, so for example, if I go back to my graph here and I add 2, see how now the vertex is up 2? It went up 2 spaces. Whereas if I were to subtract 2, it went down 2 spaces. All right? So that is a vertical translation, is when you add or subtract outside the absolute value bars. It's outside the absolute value bars. A horizontal translation, it moves it left or right. And this is where it's a little bit tricky, okay? We do add or subtract inside the absolute value bars. But when you add k, when you add something inside the absolute value bars, it actually does move it left. That's not a typo. It moves it to the left that many spaces. All right, so when there's a plus 3, let's say on the inside, the vertex moves 3 spaces, but it moves it to the left 3. And if it's minus k, inside the absolute value bars, if we're taking k away from x, it moves it to the right that many spaces. All right, this is going to be something you're going to want to jot down. You're going to want to look at. Make sure you understand that. So now, if I go back to my graph again, and I do y, the absolute value of x, and let's say minus 3. Notice minus 3, it went to the right 3. The reason it did that is because if I plug in this value of x now, this value of 3 where the vertex is, 3 minus 3 gives me 0. All right, that's why whatever equals 0, that's why it would be there. So now if I add 3, what value would x have to be over here in order to make this equal to 0? It would have to be negative 3, so that's why the graph vertex moved over to negative 3. Okay? Just very importantly to remember with these horizontal movements, if it's adding or subtracting on the inside, it moves in the opposite direction on the x-axis. So if you add a number, it moves it to the left that many spaces. If you subtract, it moves it to the right. So let's just look at a quick example here. So here's this equation, y equals the absolute value of x plus 3 inside and then minus 4. Where is the vertex? All right, so give it a shot. What do you think the ordered pair of the vertex would be? All right, so this minus 3 on the inside, this moves it left or right. All right, I'm kind of asking you left or right. It does one of them. Since it's plus 3, that means it moves it to the left 3 places, which means it's going to be negative 3. That's where the ordered pair would be for the x value. This minus 4 on the outside, it's true to name, like it minus 4 on the outside does move it down 4. So the vertex for the y value would be negative 4. So the vertex would be negative 3, negative 4. Okay. I hope that it was clear. Again, you can pause it, rewatch it. You can mess with Desmos yourself, the graphing, and just figure out where the vertex would be. You have one assignment plus your mastery check, shifting absolute value graphs in Khan Academy. And that is it. And then this is your final lesson. After this, go right to start reviewing.